Well, hey everybody. So we're starting a new unit. It's advanced bivariate applications. It's going to take us beyond what we learned earlier in the year. I believe, what chapter was that? Can't recall off the top of my head, but it was when we did scatter plots for linear relationships. We're going to move from linear to things that are curved, like exponential, things that are curved differently. Power functions. We're going to look at inference for regression, which is kind of a different topic. I'm going to start out with just reviewing, linear regression, because we have not done that in a long time. And this will just get our feet wet with it again and get all the calculator steps back into our focus and all of that. And this was actually how we learned scatter plots. It was this very example where we used powerboat registrations to predict manatee deaths. And I guess the first thing to do, well, just looking at this table, is to ignore the years. Those are good labels. We need them to help us with the domain for things like extrapolation, but we really just want to set up a cell sheet and the calculator, a spreadsheet, with the first column being powerboat registration, so this, and then the second column being manatees killed, which would be this and this. So I do have this set up. And make sure that you label, so that we have some variables that we can call on if we need to. And just type these in just the way you have them. Make sure that you're not mixing things up. Make sure that you end up with 14 ordered pairs and not 14 powerboat registrations and then 13 manatee death values, because these things do have to pair up so that we don't get a dimension mismatch. Anyway, put that in your calculator and hit pause and resume once you're done with that. All right, so I think the best thing to do with answering questions like what we have in the notes is to just go ahead and just run everything, basically. So go ahead and go to your home screen and scoot over to a calculator page, and let's just go ahead and run the linear regression. So it's under Menu and Statistics, Stat Calc. And remember that you've got two of these regressions. This is what you would do in Algebra 1, mx plus b. We're way beyond that, so we're going to do a plus bx linear regression. And the x list here, let's go ahead and call that, we're doing registrations to predict manatees deaths. And yours will probably come up with F1, so I'm going to change mine. I've actually run through this already. I did a trial run of this video, and it was pretty much garbage, so I'm redoing it. So keep that on F1, and yeah, let's tab out of there. And keep your frequency list at 1. Just remember this F1, because that's where the LSRL is going to be stored in case we need it to make predictions. So let's go ahead and hit OK. All right, so here is the form that we're in. Y hat equals a plus bx. A is your y-intercept, b is your slope. So here is your y-intercept right there, and here's your slope. Here is R, correlation. It's pretty strong, it's above 0.9. And it's showing a positive nature, so we've got a strong positive relationship. Remember, it's not going to show linearity. We need to confirm that on the scatter plot. We're going to interpret coefficient of determination later. We have residuals stored, so we're pretty much good for that. And then the next thing we ought to do is look at the scatter plot. So let's go ahead and go back to the home screen and scoot over to a stats graph minus this pink thing, and so hit enter, and you get your usual kind of amorphous little set of dots. So we want this to be your powerboat registrations, this will be your manatees killed, And so that's what the scatter plot should look like. You can go ahead and add in the LSRL since we've already come up with what that's supposed to be. So we can just go to Menu, and I think it's under Analyze, Regression, and Show Linear A plus BX. All right, so there it is, and it will give you the actual regression equation along with it. Of course, it doesn't put the hat on there, but yeah, lines up pretty well. And so that was the first thing, or one of the first things we were supposed to do. So let's leave this for the moment and look back at what we're supposed to fill in. All right, so let's look at what we've got. It says, state the explanatory and response. Remember, explanatory is X. All right, that explains what we see in our response variable. So that would be your powerboat registrations, and the response are the manatees killed. Okay, then it asked us to plot the scatter plot. Now I did this. By the way, anything that I seem to be going fast at, just hit pause. You know the drill by now. All right, I went ahead and did the scatter plot, and I even put in the LSRL. I'll talk about that more in a minute. I don't know that I need for you to do this anymore. I think now that we're getting up to AP exam time, to go ahead and make a scatter plot is a very time-consuming thing. And so if you can just do this on your calculator, like, you know, for homework and whatnot, and not bother doing it by hand with graph paper, I think that would save a lot of time and it would accomplish what we need it to do. But anyway, if you are doing it by hand, you need a title, you need labels, you need scales that are reasonable. You know, you don't have to start at 0. You don't want your scales too compressed, which would then compress your scatter plot in either the vertical or horizontal or both directions. So yeah, those are all the required elements. And then it says describe the nature of the relationship. Remember, it's positive, linear, and strong. Actually, I'm sorry, that's describing the scatter plot, positive, linear, pretty strong. But the nature of the relationship is as your powerboats registrations increase, your manatee deaths seem to increase along with them. So I have those written over here. So if you're inclined to do this, pause and you can complete it. Otherwise, we're just going to, you know, use our calculator to kind of do this for us. All right, so let's move on and see what else we've got. They do ask for a residual plot, but since we have other things that we can do ahead of that, let's do those first. All right, your LSRL, there it is. I just copied it down. Remember, it's Y hat, so it's predicted manatee deaths based on this relationship with your input being powerboat registrations in the thousands. So I did define those variables. That's pretty important. And the points for graphing, you know, in order to put the LSRL on my scatter plot, you know, this right here, I found this point as a prediction. I found this point as a prediction to either side of the domain, and then you can just connect those. So this is kind of what I did. All right. So going back to the calculator page, remember we have this stored as F1. So if you actually type in F1, see how it gets bold? I went ahead and did something low on the domain. I think it was, what was it again? Can't remember. But let me scoot up and look at it. 425 and 750. So put in 425 as an input. And there's my first ordered pair. That was represented by that first X. And then you can just go up here and copy this and go inside, delete, 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 and put in whatever you want. 750 was my other value on the other end. So I plotted those two ordered pairs, and that's how I got this LSRL right here. All right, and that's where these points came from. All right, so the slope. The slope is this number here. All right, remember, if you put that over 1, which you can do with any number, it means that there is a 0.124862 increase in manatees deaths each year that passes on average, each year that increases on average. All right? And then R, we talked about. R squared was your coefficient of determination. That was the 0.886379. Remember, that is a proportional value. So 88.6% of the variation in manatee deaths, that's Y, can be explained by the variation in powerboat registrations. Right? That was a kind of a script that we used, and it works every time. So then they wanted us to do predictions for 701,000. Okay, that's actually 701 because we kind of truncated it. So let's go in here and change that number to 701. Oops, that's not 704. And there was my prediction. So that's where that came from. All right. Now for 1995, let's make sure that's in the domain that we're given. And actually, our domain ends at 1991 right there. So anything we would predict higher than that or lower than 1977 would be predicting outside of the domain. Those are unreliable, and we called that extrapolation. Remember that? So the model is only good for the domain that created it. Anything beyond it, there's no telling if the trends continue. Okay, so the only thing that we haven't done here is this residual plot. This is my version of it, and it's really easy to do on your calculator. All we need to do, and let me just go ahead and see if I can delete that. Okay. All we need to do is to come here and change this to stat resid. And there they are. Now, looking at this, you've got a nice scatter. There's nothing too displaced left or right. There's nothing really too displaced up or down. Yeah, this is a little bit outside, but I don't think I'd quibble too much with it. It's not grossly so. So when you have a nice scatter throughout here without any kind of signs of outliers, remember outliers go up and down. Influential points are left and right, although they're both exerting influence. Without any of them, I think we've got a good linear model. If we did have anything that was influential and we removed it, we should see improvements in R and R squared, and we would get a different predictive model slightly. But here we're good to go. All right. So that's what I said. The data fits a linear model well. All right. So here are the notes for day one. The major thing is to get back into the swing of things with your calculator. And again, I did mention that the homework would be, let's see if we can scoot down, would just be like the first two, this problem and this problem. Those are the ones that I posted up for homework. All right, guys, this is sort of part two of our first day, and it's just a quick review of computer output for regression. And this goes way back. In fact, keep in mind that everything that we did in regression is still available to you on the Canvas site. I know that I've pretty much collapsed all of the cute little graphics and things that directed you to certain chapters, but if you go on the front page, you can navigate your way back into this section, and you can actually review all of the things that we learned, all the videos, all the PowerPoints, everything like that is still there. But when it comes to computer printout, we did this. We actually used this before, and it was using some kind of measure of cry count, cry count of a child to predict their IQ. And that, the context is important, but it's kind of really neither here nor there. The point here is to figure out what's what. All right, so coming here, this column, well, no matter what it's labeled here, it's labeled predictor. The constant, that number is going to be your y-intercept. So you can see it's connected there. And then anything that's in context will be slope. So that's slope, this number here. And so this is A and this is B. So you could put this together as y hat equals A plus bx, or y hat equals 91.3 plus 1.49x. Or you can go to more accuracy, whatever. Okay. Yeah, so that's how you would grab this. This is r squared, all right? It is not r, it's r squared. So that would be 0.207. So to get r, we would need to take the square root of 0.207, which I can do. Let me do that real quickly. Get my trusty calculator out of its little protective carrying case. And if we do square root 0.207, it's going to be 0.4550 roughly. So approximately 0.4550. Now it's important to remember that this could be plus or minus, right? What you want to do is go back to your slope. The slope is positive here, so we would leave that as a positive value. All right, so that's important too, whether it's positive or negative. And then your output has got a whole bunch of other things, and we didn't really pay too much attention to them. Moving forward, yes, this right here is going to be sort of important. We will be using that value. This is going to be important. This is going to be important. And this is going to be important. We're not really where we need to be to really understand those three things, but yeah, we can still, keep these in the back of our minds that we will need them. Now, these three things that are listed in this kind of pill-shaped circular thing, that's really not terribly important for us ever. All right, but again, this is a t-value, just like for a test. This is a p-value, just like for a test. And this is a standard error, just like we would set up for a t-value in a test. So we will be using all of those things. But for right now, we're going to need A and B and r squared. Okay? So how does that apply to any kind of work that you might do? Well, the thing is that I really didn't assign anything to this. I mean, this is page 6 in the packet, but I do have a key listed for this, all right? So for example, here's some computer output. Here's A, here's B, here's r squared. Remember, ignore r squared adjusted. That's just a way to minimize things that might be outliers. We really don't use it. So you can see for this one, I used y hat as predicted, operating costs per hour for airlines. X is the number of passengers. That's all listed up in the scenario here. And I got these numbers. Here's A, here's B. All right. And I pulled this out, took the square root of it, and got R. Then I defined what the coefficient of determination was. So there's a lot of this. Here's 2. It's the same kind of thing for a different scenario. Now the thing about this is, this is something 3 you could look at if you want. I have all the answers here. Number 4 here is something that has an exponential relationship or some kind of a nonlinear relationship. You can see that from the residual graph. That's kind of not so great. Anyway, there's nothing really you can do with number 4 just yet. We're on the cusp of being there, but not yet. But then if you go back to number 5, that's back to just straight linear. And this is something you can play around with. Do a few of these, 1 or 2, and except for, of course, number 4, we're not ready for it. And just get your practice in reviewing your computer output. Remember, we had computer output for chi-square. We have it for regression. It's really available for any stats procedure, but these are the 2 that we're up to speed with for now. So That's really the second part of what I wanted to cover. And yeah, just make sure that this is not a foreign thing to you. They use computer output quite a lot in your AP exams.